talk about math.
All right, so 5.1, so what else? All right, so 5.1. And I'll tell you the reason we put 5.1 here was because 8.5 was doing the same thing. Instead of having to keep doing a repeat of it, we just put it all in one section. So really, 5.1 is getting you ready for 8.5. Okay. So the first thing they want y'all to do in 5.1, and this is rational expressions. So we're trying to do 5.1. It's not very long. And then I might get to start on 8.5. So this will have like 6 questions, okay? So the first thing they want us to do is find numbers for which the rational expression is not defined. So finding numbers for which a rational expression is not defined. And basically, this is getting you ready for doing the domain questions. And we've sort of already played with the domain a little bit on these, except I will say in this section, they want us to use interval notation instead of the set builder. So define numbers for which a rational expression is not defined. You take the bottom of that fraction. So we're going to set the denominator equal to 0. And then any solutions will make it undefined. So any solutions will make the rational expression undefined. So y'all, it's basically doing a domain problem, but we don't have to write the answer in interval notation and stuff. We just got to find what numbers make it undefined. So we're going to find any numbers for which the rational expression is not defined. I want to say is not defined. All right, so we're going to start out with on number 1, 9b squared minus 10 all over 14b plus 15. Now we'll say the difference in this section versus what y'all did in the beginning. I'm going to throw some quadratics under some of these. So to solve them, we gotta have to factor or use the quadratic formula or something, okay? Yeah, your interpreter was just here. There you go.
Yeah. I need to.
don't use it, got a chair sitting up in that corner for you.
Oh,
All right, y'all, so on this problem, I'm gonna take that bottom of that fraction, set it equal to 0. And then y'all get to solve that. So we got 2 moves on this. So I'll start out by subtracting 15 from both sides. So I get 14b equals a negative 15. And then divide both sides by 14. So that cancels and I get b equals negative 15 over 14. Don't look like we can do any simplifying to that. So that's going to stay a negative 15 over 14. So in these problems, you don't have to do anything else. Just find those numbers, okay? All right, I should be able to squeeze 2 up here. So, on this one, I got a y squared minus y minus 4 all over y squared minus 10y plus 24. So we'll say on this one, since we got a exponent of 2 on this one, we're going to get 2 numbers that we got to exclude, okay? First one, you only had a exponent of 1 by the b, so we only had 1 number, okay? So I'm going to take that bottom and set it equal to 0. So at this point, since that's a quadratic equation, y'all could use the quadratic formula. But I'll factor these because all these will factor also, okay? So the y squared is going to give me a y and a y. The last sign is positive. Anytime the last sign is positive, both factors will be negative like the middle. Because remember, 2 negatives multiply to get a positive, but a negative and a negative add to keep that middle negative. So all y'all got to figure out for me are the factors of 24 that'll add to get me a 10. 6 and 4. So you got to watch out for these because sometimes people use 12 and 2. They subtract to get 10, but they don't add to get 10. So you got to watch out for them signs. And y'all, the rest of this is just setting both of them factors equal to 0 and solving this. And you'll notice once again that my final solutions are going to be opposite in sign in those factors. So the first one, I'm going to get y equals 6. And then the second one, I would add 4 to both sides and get y equal 4. Okay, so you got to watch out when you got these exponents of 2 in there. We're going to have to get 2 solutions on those, okay? All right, so now we're going to find domain. Right back here. And we know how to find the domain. The only difference is we're going to put domains in interval notation. Okay, so we're going to find the domain. And put answer in interval notation. All right, so let's see. On this one, I got, this will be what, number 3? Let me make sure I'm on the screen. See? We're trying to zoom while we go. All right, y'all got f of x equals 3x minus 7 all over x plus 7. So we're going to take the bottom, and that's why they was doing this, is just to get you back in the practice of doing the bottoms only, okay? Bottoms only. So take the x plus 7 instead equal to 0. Or you can use that little not equals that I was using in the beginning. Either way. But y'all got one move on this. Again, the x by itself is to come in and subtract 7 from both sides. So that I get x is a -7. But remember, I got to put this in interval notation, so I've got to eliminate this -7 from my domain. So your domain is always going to start over there at -infinity. You're cruising along that x-axis until we hit -7. So what we're going to do is we're going to union around that -7, because that's how we kick out those numbers, and then to infinity. So all of these are going to start at -infinity over here, and they're going to go to infinity. We just got to union around and kick out each one of those numbers. So y'all, if you get one answer, you're going to get one union. Over here, like on this one, when you get two answers, you're going to get two unions in there, okay? Because you got to go around each of them numbers. And if you remember, curvy parentheses means the numbers are not included. So the only thing we'll do on these is change up those, if that's a union, and it basically means and. Alright, so this one has a g of x is going to equal 5 divided by 2x minus x squared.
What is it? What is it?
5. 5s and s's, they all the same. But we ain't worried because we don't care what's on the top, right? So what we're going to do now is just maybe throw different type of equations at you to see what you do with them. But you're going to do the same thing. 2x minus x squared is going to equal 0. Now, if you do quad on that, put it in order. Okay? So on quad, I want this to be a negative x squared plus 2x equals 0. But it might not do it because it ain't got that third number on it, okay? It should be a 0, but I don't know if quad does them when the last number is a 0 or not. But this ain't bad. I'm going to solve this by factoring. And I'm not going to factor it like I would a trinomial. I'm going to factor it like I would if it had a greatest common factor. Because you got a 2x and an x squared. They both have a x in it. So I'm going to factor out a greatest common factor of an x. So if you factor out an x, that'll give you 2 minus x, and all that still equal to 0. Okay? Anytime I got two terms, I look to see if they got the common factor first, because that's usually the easiest way. Because now I'm going to do what? Set both these equal to 0. And look at this. If you factor out the greatest common factor and it's a variable, its answer is always going to be 0, okay? And then I would do my 2 minus x equals 0. So many things you can do to the second one, but if you want to do it in one move, move that x over and make it positive. You can add an x to both sides, and you get 2 equals x, which is the same thing as x equals 2. So notice I got a 0 and a 2 are my numbers. So I'm going to start at negative infinity. Only thing where I might get people is the order's got to be in the right order. So I'm going to hit the 0 first. Union around 0, and then go from 0 until I hit 2. Union around 2, and then from 2 I can head towards infinity. So I got two answers, I got two unions on that, okay? Now, number 5, f of x is going to equal 3x squared minus 73 all over 5x plus 13. All right, so same thing, right? Do my 5x plus 13 equal to 0.
5x equals -13.
So subtract the 13. And then once again, I'm only going to get one answer on this one. Divide by 5. And it don't look like that's going to reduce any, right? So that's going to stay a negative 13 over 5, okay? All right, so one more, y'all. And then I'll move y'all up.
Don't we write down the domain here? It's,
We need to, right?
Yeah.
So,
negative infinity to negative 13 over 5.
and in union,
Negative 13 over 5 to infinity.
there you go. Okay, so just remember, any numbers that we get are solutions to our equations, but they're what makes my actual function undefined. All right, so they always say the best for last, I guess. So we got an f of x is going to equal x to the third minus x squared plus x plus 3 all over x squared plus 11x plus 24.
We can use a quadratic formula for that in each of these, isn't it?
You can use quadratic formula because it is a quadratic type equation with the x squared on it. But I'm going to factor it because it will factor. All these in this section should factor if you want to do them by hand. So I got a x and an x. Both of these will be positive like the middle. And then what factors of 24 add to 11?
8 and 3.
8 and 3. So as long as you're pretty decent at multiplying factors, not too bad, because y'all know all the factors that get all the numbers and stuff. Right, then I'm going to make both these look like they're going to be negative, right? I'm going to have x plus 8 equals 0 and x plus 3 equal to 0. And then it looks like I'll subtract 8 from the first one. And then subtract 3 from my second. So I guess the question is, what comes first, negative 8 or negative 3?
Negative.
Negative 8. Because we're going left to right. So union around that negative 8 until we hit the negative 3. And then union around the negative 3 until I hit positive infinity. So basically your two numbers will be in the center one. And then one's on the left and one's on the right. Okay. So hopefully that was just review for y'all since we sort of did domains earlier in the year. Okay. So what I want to do now is sort of fix y'all on some of those from 8-4. And I'll knock out 8-5 next class. So, you had someone on 8-4 that was bugging you.
No, the
Huh?
the last three.
Let's see what she-
And then Carol's still on here. She had issues out of those. So I'm going to do some of those like from the last three from 8.4. So these are from 8.4. All right, so this one will be like 17 because it was probably the trickiest of the three, I thought. They're giving us f of x equals 2x to the third plus 5x squared plus 50x plus 125. So they want me to find the zeros, and actually it said find the rational zeros and the other zeros. So that would have been part A of it. And then part B, they want me to factor into linear factors. So I will say this. I'm probably going to, I would graph those just to see where is it crossing over that x-axis, because that can help you find the zeros. If not, you got to go through all the different combinations of factors like you did on that 14 and 15. So let's see, my last number is what, 125. And then my first number would be the 2. So I'm going to look at factors of 125. That is 1, 5. Ooh, what else can I get? A 25 and a 125, I think. Factors of 2 are just going to be 1 and 2. Okay. So graph that on your calculator. I wish I had a TV in here where I could play my calculator for y'all. But y'all, I'm just going to graph this just to see what it looks like on the graph. So I got 2x to the third plus 5x squared plus 50x plus 125. And we just basically want to see what the graph looks like. So if you notice, it's only got the one line going up through there. But that's not crossing on any of my actual points, is it? But if you notice, that looks like that's at about a -1, 2, about a -2.5 or so. But watch how we're going to get it. So all the possible zeros are all these factors divided by those factors. So I know it's not going to be the 1, is it? Because 1 divided by 1, 2 divided by 1 are just going to be whole numbers. But that's crossing in between two numbers. So it's either going to be a 1/2 plus or minus 5 halves, 25 halves, or plus or minus 125 over 2. Which one of those looks closest to the negative 5 halves, right? Because that'd give me about 2.5 if I was, and that looks about right where that was crossing too. So we're going to try that first, okay? The -5 halves. That's going to be my first C. Now I got all my coefficients. I'm going to bring down my coefficients from my synthetic division. A 2, a 5, 50, and 125. If I'm correct on that, what's that 0? I just gave it to you. It's got to be a 0 if I'm right on that 0, okay? Alrighty, so bring down that first number, bring down that 2. 2 times negative 5 halves. We got a negative 5 halves times a 2. The 2's cancel, so I end up with a negative 5. And then that 5 and negative 5 add to give you a 0. 0 times negative 5 halves. 50 plus 0 is 50. And then let's see, we got negative 5 halves times 50. Well, guess what? 50 and 2 will turn into a 1 and a 25. And guess what? 5 times 25 negative is a negative 125, which gives me a remainder of 0. So we know the first 0 is going to be the negative 5 halves. Now, you see 3 numbers down here, right? At that point, since there's only 3 numbers, we can use the quadratic formula. So use quad at that point. A is 2, B will be 0, and C will be 50. So doing that, that should give me 2 more answers. So I'm going to go to program and go to quad.
I got it already.
So she got a 5i and a negative 5i. So 5i and negative 5i. So here's where you got to be careful when you're putting in these answers. Because,
I see.
So the rational zeros are any of the zeros that I can make look like a fraction. Well, hell, I got one that looks like a fraction already. So the rational zero is going to be
Negative 5.
the negative 5 halves. And that's the only rational zero, because these aren't rational numbers. Those are imaginary numbers. So those would be considered the other zeros. And that'd be the 5i and the negative 5i. So if you get any zeros that are imaginary, they're going to be other. If you get any zeros with radicals in them, like square roots, they're going to be other. Okay? The only rational zeros will be the whole numbers and the fractions. Okay? So then part B said, hey, write this as linear factors. So for linear factors, they're going to give me parentheses. And basically, we're going to take each of the zeros, put them into parentheses, and change the signs. So where's my first one? Negative 5 halves. So this will be x plus 5 halves. And I'm going to show you a trick at the end. Since there's a fraction, we're going to have to put a number in the front.
2. Gotta be 2.
Mm-hmm. So watch this, Giselle, since there's a 2 on the bottom of this fraction, they want you to put a 2 in the front because that's what would clear the fraction. Now, the next zero is 5i, so that's going to be x minus 5i. And then the last one was a negative 5i, so that's going to be...
Oh, okay. See, that's what's wrong here, wrong. I thought you had to put the 2 side the x.
Mm-hmm. Well, if I was solving that, I would do all that.
Yeah.
But what they're doing, they're just putting them in linear factors. And anytime you got a fraction in linear factors, they try to clear the fraction by putting that number in the front. So that those 2's would cancel, but everything else would go up by a 2. But if they did that, then you have fractions left on it. So I'd have probably just stopped right here and wouldn't have done the 2, but MathLab does things a little bit extra. You know what I mean? So, but that's what they wanted on that, and so let's try one more of them. I want to start out with the x to the 4th.
You gotta start. Will you repeat that, please?
Oh, I want to start a new one for them. Oh. Mm-hmm.
I thought you said star fight. I'm like, okay, what is that? Okay.
That's what I call my Jedi powers. My Jedi powers. x, we're gonna start out with an x to the fourth minus 7x to the third minus 35x squared minus 41x minus 14. So I'm gonna find the zeros and then I'm gonna find linear factors. So I'd probably graph that again real quick. So let's graph that and see where that's gonna cross over that x-axis. So I got a x to the fourth minus 7x to the third minus 35x squared minus 41x minus 14. So I just want to see where that might be crossing. So if you notice on this one, looks like it's over there at the -2 and the -1. It's got a little curve. So either one of them would work. So I'll try the -1 because that's a smaller number. Now the other way, Giselle, was to take all the factors of 14 and divide all the factors by the front number, which is just a 1. So that's how I know this one will not have a fraction at all because there's only a 1 in the front. Okay. So let's see, our numbers are now 1, -7, -35, -41, and -14. If we're right, that remainder will be 0. Okay, so here we go. We're going to bring the 1 down. And then multiply 1 times -1 is -1.
-8.
Add -7 to -1, get -8. So what you do is you're multiplying to get the next number, and then multiplying to get the next number. So I'll multiply this -8 times -1 to make that an 8. Then we're going to add that column.
-27.
So -35 and 8 is -27. Then you repeat again, multiply again. So positive 27. So -41 and positive 27.
24. No, it's 17. 14.
14, there you go. You did a 10 over there. Oh, but look at this. -14 times -1 is a positive 14. That's what I needed.
0.
So that those add and give me my 0 remainder. But sadly, I still got 4 numbers. So I cannot use the quad yet until I get it down to 3. So what we got to do is bring down that 1, -8, -27, -14. And we got to find another 0 to start dividing by. So what was that second 0 we seen on there? -2, I think it was, right? So it gave me 2 zeros, but eventually I want to use them both anyway. Okay?
1 goes down.
So bring the 1 down and start multiplying again, right?
-2.
So -8 and -2,
-10.
-10. So then multiply -10 times -2.
20.
-27 plus 20. And look at that, y'all. -7 times -2 is a positive 14, which gives me another remainder of 0. So we've got 2 rational zeros so far with the -1 and the -2. So what can I do now? I've got 3 numbers left. I can use quad. That's why we give y'all that formula, because well, you're going to use a quad a lot. So throw in a 1, -10, and -7 and see what we get. And I'm predicting we're going to get radicals on this one. So I get 5 plus 4 square root of 2. So 5 plus 4 square root of 2, and then it was 5 minus 4 square root of 2. So let's see if y'all can figure out my rational zeros. Well, radicals are irrational numbers, so the only rational zeros are -1 and what was that, -2? Other zeros, And since we had an X4, we need 4 zeros altogether, so you gave me 2, so the last 2 would be what, the 5,
Plus 4,
Uh-huh.
square root of 2,
and then the 5,
negative 4, square root of 2.
square root of 2. I'm pretty sure on that, and y'all can use the plus or minus key in that and just put it once. 5 plus or minus 4 square root of 2, it should take that. Oh, what was the other thing? Linear factors.
It makes sense now, doesn't it?
So this one had 4 parentheses, right? Whoops. Let me make them a little smaller. I got people watching on that. All right, how about this? All right, so these ones won't be bad, right? -1 and -2 make this a x plus 1. All I'm doing is changing the signs, putting them down here,
X plus 2.
and then that'll be x plus 2, okay? So you just change the signs and everything. Now, both of these 5s are positive, so they're both going to become negative. And then y'all, if you make this one negative, you're going to make that positive, so it don't matter. So this is plus 4 square root of 2, and then you get x minus 5 minus 4 square root of 2. So I'm just changing everybody's sign when I bring it into my linear factors. So that should be the 2 trickier ones of those. But it is tricky figuring out what they meant by the rational zeros versus the under zeros, and then that linear factor stuff, okay? So our goal is no matter what exponent we start with, we want to get that down to 3 numbers, so we can always get the last zeros using the quad, okay? Because I doubt we'd ever guess those kind of zeros, huh? With the radicals and stuff. So that sort of fixed you?
Mr. Rathbun, can you tell me again, where did you get the -1 and
Oh,
-2
that'll be it for
that you?
today then. We'll just mainly knock out 5.1 today. And 8.5 will be our next class then, okay? So y'all good? Any questions? All right, I don't want to have a Zoom yet. All right, Carol, I'm gonna stop sharing.
Well, yeah, I was back at, where did you get the -1 and -2 that you did the synthetic division with? Where do they come from?
Are you going next door on it?
Oh, yeah, I'll be over there.
Yeah, I had issues with my whiteboard this morning, so I'm gonna see if they fixed it.
Okay.
Because I called the IT department, but they weren't there yet.